In this video, we'll be talking about neurology, and basically we'll be explaining the concept of resting membrane potential itself. Now, in the previous video on neurophysiology, on physiology itself, we have mentioned the information flow through a nervous system. And I mentioned that information flow through a nervous system is bidirectional, which means it can flow through from the peripheral nervous system to the central nervous system where it is integrated, then from the central nervous system to the peripheral nervous system where the action by the effector muscle or by the effector is being initiated. You understand? So these are the things that we have mentioned in the previous video. I've also mentioned that there are two nervous system cell. You understand? I said there are two. We have the microglia cell and we have the nerve cell itself. The microglia cells has a particular function, and its function does not perform any function in information flow through the nervous system. What it just do is it protects, serves as protection, defense, source of nutrients, production of myelin sheets, and other stuff like that. That is the function of my glia cells. And we said we have two different types of glia cells. In the central nervous system, we have the microglia cell, we have the astrocytes, we have the oligodendrocytes, and we have the epidermal cell. And the peripheral nervous system, we have the satellite cells and we have the Schwann cell. So we have mentioned all that. We have explained what a neuron looks like. We said we have different type of neurons. We have the unipolar neurons, the bipolar neurons, and the multipolar neurons. And we said the unipolar neurons, they are the ones with only one cell process, because we have cell body and we have cell process. Cell body is also known as soma. Cell process also is what extends out of the cell body. So we have two. We have the axon and we have the dendrites. So based on the number of cell process, we classify neurons into three types: the unipolar neurons, the bipolar neurons, and the multipolar neurons. You understand? So these are the things that we have mentioned. Now, how does information flow through a nervous system? You understand? So that is where we go through. That's where we get into what you know as the membrane potential. And here we're dealing with how information flow as in form of electrical signal through the what? Through the nerve cells. You understand? Since we said the nerve cell is the basic functional structural unit of what? Of nervous system. So let us proceed. Now, membrane of neurons, like all other cellular membranes, they have special permeability that creates ionic imbalances between the interstitial fluid and the surrounding environment of the neurons. And these ions in the interstitial as well as the surrounding this thing includes the potassium. We have the potassium. We have the sodium, the chlorine, and the anions. You understand? So the um the differences are in the number of ions in the interstitial fluid as well as the extracellular fluid is so well pronounced in such a way that we have approximately 10 times of sodium ion outside of the cell when compared to what? When compared to inside of the cell. We have 10 times of what? In mammals. You understand? I'm talking about mammals in this case. So we have 10 times number of what? Number of sodium ions outside and the inside. And we have about 25 to 30 times of what? Of potassium ion inside than the outside. Are you getting me now? We have chlorine ion, more chlorine ion outside of the what? Outside of the cell than inside of the cell. And we have more anions inside of the cell than outside of the cell. Now, this stuff that we're having here, they have their own function that they perform. But what we have to know is that since we are talking about permeability, something is permeable. It means it can move. You see the potassium ion, the sodium ion, as well as the chlorine ion. We also have calcium ion. But that's where we get to what? That's when we get to action membrane potential. You see these three ions, they are what? They are permeable. They can move from inside of the cell to outside of the cell, as well as outside of the cell to inside of the cell as well. But you see the anion. Anion is a protein. It is very large, very heavy, and it is heavy in such a way that it cannot move from inside of the cell to outside of the cell. That is why we have zero anion outside of the cell. You understand? Basically, it is restricted to what? To inside of the cell. You understand? Now, what is now resting membrane potential? Resting membrane potential is the voltage difference across the membrane when the cell is at rest. These people define it as, let me check. The resting potential is the difference in electrical potential across the plasma membrane when the cell is not stimulated or when the cell is at the state of relaxation. So when the cell is at the state of relaxation, when it is not passing any information, that is the voltage difference is known as what is known as resting potential or resting membrane potential. That is what we have here. Now, how is resting membrane potential achieved? You understand? Since we say something is permeable, it says say something can move outside of the cell to inside of the cell, inside the cell to outside of the cell. You know, it's like having a house. If you have a house like this is a house and there is someone inside of it. If there is no door, the person won't be able to go outside and no one will be able to come inside. You understand? Either there is a door or there is a window. Which means before someone that is inside to go outside, there must be a what? There must be a door or what? Or window. And before someone go inside, before someone come from outside to inside, there must be a what? A door or a window. Which means there is something like a door or like a window in what? In cell membrane as well. And this is what known as what? This is what we known as channel. But because we are dealing with what? We are dealing with electrical signals. You understand? We are dealing with excitable cells. You understand? Excitable cells. So we won't call them channel only. We call them what? We call them ion channels. You understand? So we have ion channel in what? In cells. Just like the door and the window in our houses that allows people to go outside and allow people to come inside. You understand? Even though it is not normal for someone to pass the window to inside of the house, but let us just say like that. You understand? So we have ion channels in what? In cell membrane. Now, the ion channels that we are having in the cellular membrane of the neuron is just like this. We're having something like this is a neuron. You understand? This is a neuron. This is the soma or the cell body. We have the dendrites all around it and stuff like that. But I don't really need the dendrites. You understand? What I just want to zoom in on is the what? Is the soma. So let me just I'm trying to like zoom on this part. You understand? I'm trying to zoom on that part. You understand? Now, zooming on this part, we are going to see something like this. I'm going to have something like this with channels, something like a window, different channels. So we have all these channels. All these things look like a what? Like a window. That something can move outside or inside of the what? Of the cell. So if I zoom it in, this is what I'm going to see. You see these things? They are called what? They are called channels. They are referred to as what? They are referred to as channels. And they allow the what? They allow the permeability of ions outside of the cell to inside of the cell or inside of the cell to outside of the cell. You understand? So these are the things that we have there. Now we now have 3 ion channels in the what? In the soma. We have 3. I'm going to list that 3. The first one is sodium ion slash sodium potassium ATPases. We have the leaky potassium ion channel, and the leaky sodium ion channel. So these are the what? These are what we are having. So we have sodium potassium ATPases, potassium ion channel, and the sodium ion channel. Now, what I'm supposed to explain, how I'm supposed to explain it, is in such a way that I'm supposed to use a neuron that is a neuron at the what that is next to an effector muscle. But why can't I just use a post-synaptic neuron? I will tell you what a synapse is. A synapse is a gap between two neurons. A gap that is used to transfer what? To transfer information between two neurons. So if you have two neurons like this, you see this gap here? This gap that I bridge in pink, it is what? It is the synapse. So I call it a synapse. So any neuron that comes before the word, before the synapse, is termed the presynaptic neuron, and anyone that comes after the synapse is known as what? As a postsynaptic neuron. So let me just use the presynaptic neuron to explain. Now, the presynaptic neuron has already received a stimulus and it has been passed through the what, the stuff like this. And next thing is to be passed onto the what, onto the postsynaptic neuron. Now the postsynaptic neuron, before it transfer information, it is at resting membrane. You understand? It is at what? At resting membrane. So this is what I want to zoom in on this. I want to zoom in to explain this particular aspect. Now, if you zoom on it very well, you can see there are channels. There are channels. Look at it: the potassium channel, the sodium channel. You understand? Now you can see that there is influx and exflux of channel of materials outside to inside, then inside to outside of the what, of the this thing. Now this is what is going to happen. I'm going to draw my own instead of this one that just look a little bit complicated. You understand? You can see that outside of the cell we have sodium ion, and inside of the cell we have potassium ion. Now let me just try to sketch the one out here. Now look at this. We have the sodium potassium HPases. This one in this. We have the sodium ion channel, sodium ion channel, and we have the potassium ion channel. This is potassium ion channel. You understand? Potassium ion channel. Let me just now put potassium inside of this cell. Now this is potassium ion channel. Potassium ion channel. Now, what is going to happen first is that I want to make the inside of, because according to this, the inside of the cell will be what? Will be negative, and the outside of the cell will be what? Will be positive. Now, how is inside of the cell negative? How is outside of the cell positive? The resting membrane potential is around minus 70 millivolts. Minus 70 millivolts. Now, this is what is going to happen. Now, you see the sodium ion, the sodium potassium ATPases. What it does is that it opens. You understand? It opens, and the don't let me explain the sodium potassium ATPases first. Let me start with leaky potassium ion channel. Now, for leaky potassium ion channel, what it's going to do is that what? If you look at it very well, we have more potassium ion channel than the what? Than sodium ion channel. For my illustration here, I have 5 potassium ion channel and I have 3 sodium ion channel. So I have far more potassium ion channel than sodium ion channel, which means a cell is more permeable to what? To potassium than sodium. Now, inside of the cell, we have potassium, we have what? We have anions as well. Having potassium and what? We have potassium, we have anions. We have potassium, we have anions. We have anions everywhere. You understand? We have anions. We have anions. You understand? We have anions. As we're having anions, we're having what? We're having potassium as well. So we have potassium, and we have potassium. You understand? Now, because according to general law of electricity, like charges repel, unlike charges attract. It means anion being negative, we attract sodium being positive to form a what? To form a neutral molecule. You understand? Which means for every sodium, we have what? We have an anion that is bonding to it. Are you getting me now? Now, the inside of the cell is about 0 millivolts. Let me say 0 millivolts. Are you getting me now? Now, because at resting membrane potential, the inside, the sodium, the potassium channel, the potassium ion channel opens. You understand? Once potassium ion channel opens, this thing flows outside. Potassium flow outside of the cell. You understand? It flows outside of the cell. They flow outside of the cell. Leaving what behind? They are leaving anions behind. Which means the outside will be what? Will be positive. Because more positive is being flowing outside of the cell. The inside will be negative because more positive is flowing from inside of the cell to outside of the cell, and we are leaving negative behind. You understand? So because potassium ion is flowing outside of the cell and we are leaving anion behind, it makes the inside of the cell to be what? To be negative. And it moves to about what? To about 90 millivolts. Minus 90 millivolts. You understand? Now, as it moves to about minus 90 millivolts, we have a lot of potassium ions that is flowing outside of the cell. You understand? They are flowing outside of the cell. What is now going to happen is that as potassium ion is flowing outside of the cell, that makes the inside of the cell to be negative to about minus 90 millivolts. Sodium ion will be what? Will be flowing inside of the cell. Will be flowing into the cell. You understand? They will be flowing into the cell. And as they are flowing into the cell, because the number of potassium ion that is flowing outside of the cell is more than the number of sodium ion that is flowing inside of the cell, it won't be able to bring the cell back to what? To 0 millivolts. You understand? Hence, we are going to have something like minus 70 millivolts, because the inside of the cell will be what? Will be a little bit negative. Will be a little bit what? Will be a little bit positive. You understand? From what? From minus 90 to minus 70. And remember that I mentioned here that the resting member potential, it is what? It is minus 70 millivolts, which means this is how the cell achieve the what? Achieve the resting member potential. By what? By opening the sodium ion channel, a potassium ion channel, for potassium to flow outside, leaving more anion inside. Why is anion being left inside? This is because we have a house, for example. We have a house. Sorry, I have to. We have a house with this type of window, or let me say door, for example, with this type of door, and inside of the house we have a chicken. Sorry, don't mind my chicken. We have a chicken. Are you getting me now? And we have, let me say, an elephant with its talks. We have an elephant. You understand? Now, this chicken is what? Is potassium, and this elephant is what? It is what? It is anion. You understand? Now, it is easy for a chicken to pass through this what? Through this door outside of the cell. You understand? Outside of the house. But it is not easy for an elephant, because the door is too small. It is not easy for an elephant to go outside of the what? Outside of the house, because the door is too small. Now, I've already mentioned that anions are large proteins. They are macromolecules. They are large proteins. So the channel that they are supposed to flow outside, as the potassium is flowing outside, the anion is trying to flow outside as well. But the channel that they are supposed to pass is too large for them to, or is too small for them to pass. That means they are too large for them to pass through the what? Through the channel. You understand? So zooming into this particular aspect, look at it. You have this. Zooming into this particular aspect, we have what? We have the channels. You understand? And inside the channels, we have the sodium. We have the potassium ion channel. We have the sodium ion channel, and we have the sodium potassium ATPases. Even though I have not explained the function of sodium potassium ATPases, I'm going to explain that when we get to what? When we get to action membrane potential. You understand? That one is quite easy. Now, what is happening is that more potassium is flowing outside of the cell. Anions are staying inside of the cell, making the inside of the cell to be what? To be negative, to about minus 90 millivolts. You understand? And more potassium that is flowing outside, more sodium is flowing inside. But there are more potassium. The cell is far, far more permeable to what? To potassium than sodium. So let me just represent that with this. The cell is far more permeable to potassium, far more permeable to potassium than what? Than sodium. You understand? Which means there are more potassium that flow outside of the cell than sodium. And what does this create? It creates what we know as concentration gradient. You understand? Concentration gradient is being created among the what? Among the cell. I get me now. So increasing the concentration of potassium outside of the cell, I get me now, and decreasing the concentration of potassium inside of the cell. I get me now. So this is what happens in what? In the formation of rest membrane potential. Now, it should be noted that there are other ions that can move in and out of the cell. In and out of the cell. Like calcium, chloride. We can have calcium ions, I must put ions. Calcium ions, chlorine ions. But we are only considering the main ions, and these main ions are what? Are the sodium ions and the what? And the potassium ion. This thing has a little bit of calculation, and this calculation we have the equation. We have the equation E K plus equals to 61.5 divided by Z multiplied by log uh, log 5 over 140. And what is 5 over 140? That is the potassium ion gradients at outside of the cell divided by potassium ion gradients inside of the cell. If we calculate this, we are going, it is potassium ion, we are going to be getting around minus 90 millivolts. You understand? We are going to get around minus 90 millivolts. It might be approximately and stuff like that. So we are going to get around minus 90 millivolts because it is the potassium that brings the cell into minus 90 millivolts. So if we want to calculate for sodium, we just say plus sodium plus equals to 61.5 over Z multiplied by what? Multiplied by log of what is inside of the cell. That's 150 over what? Over 15. You understand? So if you want to if you calculate this, we are going to be getting around minus 70.4 millivolts. Minus 70.4 millivolts. Because it is the sodium that brings the what? The inside of the cell to this thing. And the Z is always like 1. You understand? So that is what we have for what? For resting membrane potential. So in the next video, we'll be talking about the graded membrane potential and the action membrane potential. Thank you so much for listening and subscribe for more.